So just to recap, guys, what we've got is we've got 5 nodes here running StorageOS in a standard Kubernetes cluster, and we've got some Postgres database pods running on those nodes. Now, what we want to demo for you is how StorageOS can help us make those databases high availability. Of course, with databases, we can do lots of high availability tricks, but StorageOS really makes it easy to make databases HA without needing to reason or worry about any of those special concerns. So a quick reminder, when a container writes to its primary volume, StorageOS helps us with synchronous replication. So the write pushes down to the primary, across the replicas. The replicas all act that write back, and then the primary finally acts that write back to the application. And that means that when we fail a node, we can move the mount point, and our Postgres pod can carry on working without any user intervention and avoiding alarms and alerts and wake-ups and so on. So Ferran, over to you for the demo.
Thank you, Paul. That sounds actually fantastic, right? That sounds like I don't have to get up at 3 a.m. in the morning ever again. And as an engineer that I've been on 24/7 rotas for quite some time, that is actually great. And it sounds great. So let's go and do it. Let's go and shoot things. So let's get into the cluster once again. Just to recap a bit and to give you the context, we have 5 worker nodes, and StorageOS is running on every single one of them. So we had data, we had different nodes, we have different applications, and we can see, and we want to go and fail one of the nodes. Which node? First of all, let's go and exactly see which node do we want to shoot. Or actually, I'm going to shoot any of the nodes, but let's have a bit of a dramatic effect. I can use also the StorageOS CLI. So instead of using the UI that you have seen already, let's do a bit of the command line interface with StorageOS. Let's have a look at all the volumes that we have available on that specific cluster. You can see, we can make that a bit bigger maybe. No, here it is. So we have, for every namespace, 1 persistent volume created. And that persistent volume is located in one specific node, the primary volume, and attached, second column, on either the same node or a different one. So now you can probably understand why one of my nodes, worker 2, was cordoned. I couldn't run applications there, because now we can see that even there is data on worker 2, for instance, this volume is in worker 2, the app0 namespace PVC is in that specific node, data is there, and we have a second volume in worker 2. We have 2 pods that are running, 2 instances of database that are running on a different node. Why is this important? In case of failure, whether your data is in one place or another, you have to be able to start your containers anywhere in the cluster. And that is really, really important for high availability. Yes, we have a failure. Yes, we need maybe to restart an application, but the data is accessible. First layer of protection. We can start anywhere in the cluster. Second bit, let's go and shoot the node that actually holds data. So here, let's target app0 namespace. So if I go to app0 namespace, we can see, once again, primary volume, first column, is allocated in worker 2, while its replica is allocated in worker 4, the second column. So we can see here on the second column that there is a replica hosted and located in there. A different tab, I will have the specific volume. So let's go to the internals of the volume. So we have the volume page. I don't have to read too much now. Just keep in mind, node worker 2 is where actually the data is stored, the primary volume stores the data, and worker 4 is where it's synced. While the application, remember, the Postgres database is on worker 4. Let's double check that though. So instead of taking my word for it, you can see that the database is on worker 4. Again, I didn't make a mistake. Here we are, worker 4. I'm going to go shoot the actual node that holds the data, worker 2. Because honestly, it's the one that is most interesting to shoot. What happens if I lose the node that has data? I have a shell to every worker node on my machine, my cluster, worker 2. So you all can see that I am in worker 2. Here it is, worker 2. Reboot. A matter of seconds, I can see that the health check of the StorageOS is already telling me that there is a node offline. If I go to the specific volume, I can see automatically that where I had the replica, now I have a master, and automatically a new replica has been provisioned. Because there's a couple of hundreds of megabytes, the replica is almost instantaneously provisioned and synced. If I had 100 gigs of data, I could see here an ETA saying you're going to take a few minutes to have a fully synced copy of the data. In the meantime, I can keep reading and writing to the application, no problem. The application still is attached. It didn't move. I just shot the node that holds the master, right? Let's go have a look at the application itself. Same pod as before, still running, no restarts. Let's get into it. Once again, we can see if we list the disks that the mount is there. Let's go into the data itself. We can see that we have data from Postgres. I can touch a file, I can write to it. So actually what happened is we moved everything under the hood. The data what I was writing, or this application was writing, went away, and nothing happened. On top of that, we can say, okay, this is declarative, and it's great that it's declarative, but I need more than the target of one replica. Let's go and create a second one. So we say, hey, StorageOS, sync a second replica. And again, because there is not much data, it syncs almost immediate, or actually in a matter of milliseconds. We can keep reading and writing to the application. Our database is safe. To recap a bit, Paul can give us more about what we just did and how the database is high available and how we can run, in this case, a relational database with high availability just by having Kubernetes and StorageOS.
Thank you, Ferran. That was fantastic. Well, wasn't that exciting? Just to recap, guys, what we've managed to do here is in a live demo, we've rebooted a node that's hosting data, and we've kept our database running. So first of all, a few points to make here. StorageOS makes HA really, really easy for all applications. We really don't need to think too hard before we turn on synchronous replication. Secondly, orchestrators, StorageOS, and Kubernetes will converge. They'll automatically heal our environment. So no more 3 a.m. wake-up calls. I too have been woken up at 3 o'clock in the morning on support rotas. It's painful. We can help you with that. And thirdly, I wanted to point out that StorageOS can automatically space data, can deterministically place replicas across availability zones. And this gives us a form of DR within cloud environments. So we can simply arrange for these applications to be spread across availability zones, and we've got disaster recovery.
Whenever I see something crossing availability zones, especially network data, I think about the egress charges for moving data between availability zones. So I'm wondering how efficient the replication is in terms of keeping the amount of data actually being moved minimal, and if you can control how often, or I guess not how often because it's synchronous, but if there's any controls you can put around that. That's
a really good question. There are two topics to talk about here. One is you can compress the volumes if that is worrying. So you can enable compression, and we will actually have to sync less data. And the second point is the partial sync, what we call a reconciliation of data, or a delta sync. In case of a node go down, you will have, or StorageOS creates a new replica. And that new replica might go to different availability zone, and you might have to sync 100 gigs of data. But if that initial node that failed comes back up, following a reboot, for instance, or a patch, StorageOS does a delta sync of the differential of that and just resyncs that specific chunk of data and removes the new replica that was about to be created. Therefore, you don't have to sync everything.
In addition, it's worth noting that our replication streams are very aggressively compressed. So we do all we can to minimize that data flow across the egress boundaries.
Okay, cool. And if I have sort of a distributed application that wants to hit that database backend, is it possible to have like a read replica in each availability zone so I'm not constantly reaching across AZs to pull my data?
So we don't support a read replica in the way that you described, because of course with POSIX mount semantics, it's somewhat challenging to achieve that. Back to the previous conversations about the laws of physics. However, I will note that StorageOS locality does help us here. So of course we do make sure that that database pod gets placed on the same node as the primary volume. So typically we wouldn't expect to see egress charges or bandwidth or latency costs for this kind of work.
Right. Yeah, I know. At least as far as the way that AWS is constructed, any traffic that moves between AZs, you get dinged on an egress charge, which I know it's buried in the legalese somewhere.
Now you're saying that, actually, it's worth noting that what some people need is actually the high availability on multiple availability zones. And either, they have the charges for that, but you have, for instance, EBS is not being able to go across AZs. So in case of failure of one of the AZs, you not only have the problem of your application running somewhere else, is that data is just not there. Mm-hmm. But you have to pay for it. Right.
Well, there's always a cost, right? Is there an option for something that's more asynchronous if you wanted to replicate to a cluster that's in another region for like for true DR?
Not at the moment, but that is absolutely on the roadmap. So we very much want to build that. It won't surprise you to hear that we hear that feedback a fair amount. So yes, we're certainly going to build async replication.
Are you working with any backup type vendors to support the solutions that are out there and sort of lend some of the features you have buried in StorageOS to those backup vendors?
Yes, definitely. So we're working with providing a snapshot capability that will integrate with the CSI snapshot standards that effectively would mean that any backup provider would be able to back up StorageOS volumes that way.
Okay. And I swear this is, well, maybe not the last one, but I'll give some other people a chance. Is it possible to export or present the StorageOS to something that's outside of the Kubernetes cluster? Like if you wanted to, expose the storage to a virtual machine or something along those lines, is that a supported scenario?
I'm glad you asked that. That's exactly the types of services that we're building out to effectively extend both shared file systems and volumes into the sort of the beyond Kubernetes space, specifically to allow that the enterprises to make that transition when they have some parts of an app in their traditional space and some parts of the app in the new Kubernetes space.
Right. Yeah. You started at the very beginning of the presentation. We talked about supporting hybrid and legacy, and I was just curious how StorageOS ties into supporting that legacy workload.
We'll come back in a few months and expose all of the new features, I'm sure.
Okay. Sounds good. Thank you.
So this is really cool. One of the things when I'm looking at this, thinking about use cases, public cloud versus private cloud, et cetera, I'd like to know more, like, what is the adoption rate for public cloud for the solution? I think this solution, at least for me, it looks really, really powerful for on-prem. So if I'm doing my private cloud, I've got a lot of capabilities, but it seems like a lot of complexity at first view when I go to public cloud. The database thing is cool, but I can leverage other things, right? RDS, et cetera, things like that. What is the feedback, or what can you guys talk about that? What is the adoption rate for public cloud?
I think it's probably safe to say that it's, it kind of oscillates, but it's almost 50-50 at this stage between public cloud and on-prem. In on-prem configurations, obviously you're kind of having that advantage of creating like an enterprise storage layer on top of commodity environments. In the cloud, you're applying data services, and that can be for a number of reasons. It could be for the replication across AZs. It could be for the encryption. It could be to actually kind of taking the similar sort of model to commoditizing local disk, commoditizing the local disk in storage optimized nodes, for example, in cloud instances, right? It's often commercially and operationally better to have a smaller number of dedicated storage optimized nodes that might have, faster SSDs and better price points, and then share that storage out using StorageOS as well.
Okay. Okay, cool. Thank you.
All right. I think what is on everyone's mind over here is this does look amazing. What does this cost? I looked on the website and I saw that I could have a free developer license. That sounds great, but am I sure I want to dive in? What magnitude of cost are we looking at here?
We have a free developer edition that provides you the capability for up to 5 terabytes of storage and 5 nodes. Beyond that, it's a simple subscription on a per node basis. That subscription can obviously change based on how many nodes you're buying and the size, but it sort of starts to around $1,000 per node.
So is it per node, per terabyte, a mix of both, in terms of pricing? How's that look?
It's primarily by node. We kind of find that the size of a cluster is a good way of kind of valuing the workload and the complexity of the environment, and therefore the value that StorageOS is providing that environment.
Also, that all the functionality that we saw in the demo today is on the developer license. Every single thing that you've seen, it's actually the cluster that had a developer license.
And that's $1,000 per node per year?
That's right.
Month?
Per year.
Just clarifying.